Alright, so welcome guys to another live stream. Today we're actually going to be adding in the first enemy to Archipelo, so here I guess I'll just show you guys what we did last time. But yeah, we're going to be adding in some little slime guys, so I'm going to make some placeholder art. The pixel artist that we have, Landon, he actually made a slime art, but I'm not too sure if he wants to add it in the game just yet. He might want to adjust something, so I just asked him. He might let us know during the stream if we can actually use it. But yeah, we're just going to make some placeholder art first, and here I'll just show you guys what we did on the last live stream. I'll also tweet it out and put it on Discord. There you go. Alright, once again, as usual, let me know if the stream health is a bit gross. Because it might not be that great. So just let me know. Hold on, I'm just going to make sure the stream is actually public. I'm sorry I'm a little bit late. But I forgot to eat breakfast, so I had to do that first. Otherwise, I'd be hungry the whole time. I don't want to eat on stream. Okay, so we have the server running, and I'll start the desktop. Welcome everybody, welcome to the stream. If the quality is a little weird, just let me know and I'll adjust the settings a bit. Oh, also the Twitch alerts should be working now, so when I get a new subscriber, last time it was just doing a sound, but now it should actually display it on the screen. Here, actually, I'll do a test real quick just to make sure it is working. I can do that in the thing. Alright, so last time we added in the sword animations. You can see it kind of changes color randomly, which is what we want because we can have different kinds of slicing. Of course, it's just using placeholder art, but now we'll actually be able to test it out with some enemies. So we're going to be adding in an enemy spawner that will automatically spawn them in, and as well as some enemies with some basic AI. We're not going to do anything complicated. But yeah, it should be fun. And we also added in the sound effects settings in the back end. If we have time today, I guess we can do the front end, but I was thinking we're working on the map editor if we have extra time after adding in the enemies. But yeah. Okay, I should be able to test out the subscriber thing. Yeah, there you go. Although the image I have isn't showing up. Oh, yeah, it did now. I'll try it one more time. Yeah, there you go. Alright. So yeah, let's add in the enemy. Oh wait, I still have some debugging output here. Let me just remove that. Oh, I think I'm listening to my own stream so I can hear the audio. Here, I'm going to turn on the resolution of it. Otherwise it's going to lag the upload. Okay, so chat disconnected. Okay, reconnected again. I don't have any drop frames on the stream though, apparently, so that's good. Actually, that's a first timer, so up, then we have a left. Here, and we'll give him little eyeballs here. Okay, then we have down. I think an actual slime would look more like this because you'd kind of stretch, right? Here, let's see how this looks. Yeah, that's kind of more the movement. Of course, it's too fast like this, but I think it's more the kind of movement that an actual slime would have if this wasn't placeholder art. Okay, and for the right, I'm just gonna copy this. Whoops. Up, left, down, right, and then it's up, left. Actually, this looks more like up, left. Here, I'm gonna make it a little less bad because this doesn't look very good. So this looks kind of like up, left. So I'll move it down here. And then for the up, I'll do kind of wider circle like this, and then a thin, whoops, and then a thinner one like that. Okay. And then this, we can just mirror image, whoops. And then we have down left, which I'll actually just copy like this, but I'll just add a face. And then down right like this. Give it a little bit of a face here like that. Looks a little weird. Sure, that's fine. Alright, there you go. So I'm just going to make an animation for each direction so we can test it out just to see what each one looks like. Oh, whoops. I think I messed this one up here. Okay, so let's try them out. That's up, left, down, right here. And let's see if you guys don't see. Whoops. Right, animation number 4 messed up here, like that. Okay. So up, left, down, right, up left, up right, down left, down right. There's just one little thing here I find is a little annoying. It's this thing here. Oops. Alright, so let's export that. Archipelo client. So now in the test sword, we're going to put it in the entities folder. We'll just call this entity a slime. But we might change the name. And this animation, we'll call it move. Okay, so now I'll show you guys how to actually add in entities into the game. And it's pretty nice, actually. I'm pretty happy with the way it turned out. The way I ended up designing it. So let's refresh this. We should have the slime folder added in. Yep, slime right here. There's our animations. So basically, to add in entities, we have JSON files here that describe the entities and the different properties they can have. So let's create that. We'll just call it a slime of JSON. So since we call that slime to start out with, we're gonna have to be consistent all the way because that's the unique ID of that entity type. Yeah, I'm just gonna close everything else. I'll open up another entity definition file, just so I have an idea of what kind of properties there are and how it's used. Because I don't remember for sure. I'm going to have to start documenting this stuff in GitHub. I think I'm going to make a bit of a wiki for the developers so they know how to add in things like this. Okay, and we also need, I'm also going to open this up here. Entity type data, which is just the actual file that the JSON is templated off of. Okay, so there's a few things we need in here. So we need the ID of the entity, which is slime. Hittable is true because we can hit this entity. We can also give it a speed. I'll give it, I want to be a bit slower than the player, so let's say 40 pixels per second. Even that's fast, I think, for a slime. We'll do 30. Max health. Let's give it, it shouldn't be too strong, so we'll give that 30. Footstep sound. Slime, although I don't think we're going to use footstep sounds. Although slimes could have a footstep sound, it'd be like a kind of noise, you know, like some gooey thing. Image width and height, so we did it as 24. I don't know why I put it in quotes here. It's a number. View rect width and height. So this is just for the entity when it's being rendered. I don't render entities that are outside of the viewport of the player screen. So this width and height defines where the viewport is and how big it is. So of course most of the time it's the same size as the image height and image width. But some entities we might want a bigger one for some reason, or you know, different reasons. Or maybe even a smaller one if you want to kind of disappear. But I use it for other things as well too. Yeah. Actually, I think I also stretched the images of the different entities to that size as well. So footstep X. Okay, so that's where the X is of the foot of this entity. So for this one, we're just going to use the center point of it. Oops, that's the player. We don't need that anymore. So we'll do half of 24 for the X. So 12. And for the Y, we'll do something lower, maybe 8 like that. I think it'd be good. No, we should do smack in the middle. We'll do 12. Draw order X. So, sorry, draw order offset Y. We'll do 12 as well. Basically, that determines the ordering of which entities will be drawn at. But this is just the offset of the actual coordinate of the entity. So it has to do with the way entities are drawn on top of each other and stuff. Hey, sorry, I didn't check chat. Why am I using JSON? Well, it's already built into libgdx, which is nice. So basically with JSON, I can just create a class like this with public fields. And libgdx will look at this class, and it will load in the JSON fields with the same names and put them in there, and then basically I have an object of this type. So it's kind of nice. So it's not super fast or anything, but it's fast enough for the purposes that we have, and it's nice and simple. And I can also create this class in the code and then export it as a JSON file later on too if I need to. So it's nice for the when we do the map editor, we can easily export the JSON using the same class, which is cool. So yeah, that's why I use it. What else do we have? We have the collision rex. So basically that's an array of collision rex that the this entity has. So of course the slime only really has one. Even the player only has one. So actually I thought the player had a foot at one point. No, that's its only collision rex. Okay, I see. So offset X is 0. Yeah, it's pretty cool. The way I used to do it back in the day with the old Archipelo, before I restarted making it, like, that was 2 years almost now. I was basically making my own file format that I had to load in. So it was much longer, and it was, I don't know, it wasn't as, it was harder to format because I had some issues with my code with it. So instead of like rewriting a better, you know, like loader, I just decided to use the built-in one in libgdx because I thought it was pretty nice. So, and then the width and height will just be the width and height of the slime. Hold on a second. Where's the image of the slime? Maybe I'll do a little bit of an offset because it's kind of in the middle. So if we do offset of 2 pixels and the width and height will make it 4 pixels smaller. Like that. Okay, and we have animations as well. There's a couple other properties that aren't in the player class that we'll have to do. Hey, how's it going? So I have animation ID called move. The file name's also move, so I don't have to specify it. Total runtime is how long the animation runs for in seconds. So I'm gonna make it pretty long, say maybe 0.8 seconds. We'll see how that looks. We can always adjust it later. And number of directions. Although I want to change that number of directions to an entity specific thing, not for each animation. Maybe not actually. It might be better just to do it this way. I'll have to think about it a little more. So there's 8 directions to the slime. Most enemies in Archipelo will probably only have 4 directions though, just to, so there's not as much art, because it can be really annoying doing 8 directions for art. Yeah, like the player was already a real pain to do. So doing it for each enemy type would be even worse. Yeah, my internet's not super great either. We only had like less than 5% drop frames now. The main issue is that I'm not connected by Ethernet to my router. I'm connected wirelessly, so it's pretty. It's not that good. I might get a LAN over power adapter. Thing is, though, where my computer's situated, I don't really have any open outlets that aren't used. I pretty much use all the outlets around here. Personally, I prefer Eclipse, and from what I've seen, it's used more in actual industry for Java programming. But I mean, they both have their advantages. IntelliJ I find looks nicer, of course. It's probably simpler to use, although there's a few weird things with IntelliJ, and it's a bit slow. It compiles pretty slowly. I find Eclipse is nice and fast. It's older too, so it has a lot of support for different plugins. There's like a huge library of them. So yeah, if I'd have to choose, I'd just stick with Eclipse, mostly because I'm used to it. Although I need to learn more, like shortcuts and stuff, but I do use both though. For school, we're actually required to use IntelliJ, so I don't really mind switching back and forth. I think they're both pretty good. Yeah, I just think I think that Eclipse definitely looks more clunky, but in the backend I feel like it's well written, the code, because it's nice and efficient. But I feel like IntelliJ looks nice, visually, but in the backend I think it's a bit clunky. It seems kind of slow. Anyways, that's just my personal experience I've had with it. Okay, so we added this. Now, there's probably a couple of settings here I forgot to add in. Number of styles. We're only going to do one slime style, although we can do other ones. Max health, we already got the speed and everything. There are sounds that we can add to the entity, so it can do different sounds. That's aside from the footstep sounds. This are things like, just say we have like a, I don't know, like a lion or something. He can like roar or whatever. Property definitions, we're gonna have to write those. So for the slime, we're going to have a couple of properties. Okay, so actually I'm gonna have to load up the property definition so that I remember all the attributes of it, although I don't think it's a lot. Property definition. Okay, so there's a couple things here. So we have the name of the property, the type, and whether it's required or not, and this array thing we can kind of ignore, at least for now. It's still a bit developmental. I don't even know if that's a word. It's still in development. Yeah, IntelliJ has its perks, but Eclipse does also. The one that nobody ever talks about is NetBeans, though. And how's it going, Raging Rabbit? Glad you can join us. Alright, so you have... Okay, so what properties are we going to have? So the way I kind of want to do it is... Here, I can always take out paint. So just say we have like our little slime dude here. And then we have the player running around. So basically, for the slime, or for most enemies actually, there's going to be two zones around it. So there'll be one zone, which I'll call the activation zone. So this is the zone You can see my mouse cutting out there. It's still glitchy, like I was telling you guys last time. So the activation zone is the zone where when the player enters it, the enemy will start following the player around to try to attack it. And then there's going to also be a deactivation zone, which will be bigger than the activation zone. It'll be probably like this. And that's the distance that the player has to be away. Like you'd have to be outside of that zone for the slime to stop following it. So basically, when a player comes into the activation zone, the slime's going to start following it to go to attack it. And if the player manages to get out of the deactivation zone, the slime will stop following it, and it can either pick a new target within its activation zone, or just stay idle, or just move around. We can give some sort of AI for that as well. So that's kind of the idea. So basically, the deactivation zone is farther, so that the player doesn't just enter the activation zone and then they can just exit out real quick and the slime will stop following them. It's more like they have to really run out of a farther distance to get away from it. So I think that'll be pretty cool. Oh, congrats on finishing school. So yeah, I think that'll be pretty cool. So let's actually add these in. So basically these property definitions are just saying what properties there are for when we load in the entity. So what other properties are there besides, these ones? Well, not besides these ones, but beside like the animations and stuff. Because some entities have different properties than others. That's why we have to define it in here. So we'll call it activation zone distance. And we also have to give it a type, which you can see the types here. So there's integer, there's float, where you can just do number. There's double decimal, which is all gives double in the end. You can even specify a point, so like an x and y coordinate. A location, which is also an x and y coordinate, but I think it also contains a map and island ID. Direction properties, so this is for direction, rectangle, all that stuff. So for this, of course, we're going to be using an int, because that's all we need for that. And we won't make it required because we'll have a default value. Actually, for the most part, we're probably not even going to actually define the activation zone, because we're probably just going to use the default one for slimes. So yeah. And we also need to add in the deactivation zone, which is also an int. Let's call it like that. And I don't know if there are any other properties we should be doing for the slime. Let me check here if there's any other things. Oh right, default properties is not the one I should be overriding. I should be overriding properties like this. The default one is just specific to all entities. So all entities have a style, a direction, a health, and they all have a position in the game world. Okay, so now we have the definition for the slime. Let's actually add it into the code. Okay, so in here, entity type. So basically this is an enum that will load up the different entities. I'll call it slime. And we're going to have to create a slime class, which we didn't already, but here, I'll just put it there, slime.class. And I think this actually, oh no, we have a wizard. The wizard doesn't do anything though. But I was going to say this actually is the first living entity that isn't the player that we're adding, but well, it's not necessarily true, but the wizard doesn't really do anything, it just stands still, so I guess it is. And this extends the living entity. Okay, there you go. I mean, I don't even think we're going to have to actually do any other code on the client. I don't think it has any specific components on the client it needs to use. And it uses the animations as well, so yeah, I think we're good with that. It's just going to use the default animation manager for entities, so that's okay. But on the server, of course, we're going to have to do a little more because we're going to have to give it AI. Okay, so let's create the slime class first, unlike what we did before. Class slime. I was going to do slime.java, but we don't need that. Living entity. Oh, right. For the slime, we're actually going to have to define an animation, like an idle animation. So of course we didn't actually draw out an idle animation, but we can use the move animation file and set the total runtime to 0, so it's just going to stay at the same frame. I think I call them default for idle. Yeah, default. Like that. Total runtime. Zero. Of course, it has 8 directions as well, so number of directions 8, and we'll set looping to true. Okay, it looks good. Okay, so with living entities, there's a couple of methods that we need to define here. So there's one for isMoving. So we're gonna have to handle that later. Hold on, I just need to check the code for the other entities to see how I'm adding in the components. Footstep player component. Okay, so this is for playing footstep sounds, but this is just for the player. I should probably actually change this up a little bit. It's okay, I don't want to deal with this. Wait, hold on. It says footstep. Oh, okay, player, not as in like a player of the game, like player as in it plays the sound. I don't like that class name, I might change it. So for the slime, for now, we're not going to use this component, because this component basically just adds in a footstep sound for when the entity is walking. But we're not going to use that. Also, I should call this animation walk just to keep some consistency, and also change the file name to walk. Okay, there you go. And how am I doing it for the player here? Let me just check. How am I loading in the components? Okay, I'm doing it in the create. Okay, so basically I'm going to have to create an AI component for this type of entity that will make it follow the player around. So let's do that. What should we call it? Call it monster follow component. So components, entity components, are basically different behaviors of different entities, but we put them in components so that we can reuse these behaviors with different entities. So it's kind of a good way of not wasting as much code, but also being able to you know, have something consistent, and we don't have to fix bugs everywhere. We can just fix it in this one component. So it's pretty nice. Okay, and it needs a constructor. Okay, so that saved the entity in. We should make sure that it is a living entity. So we're going to specify that here. And I'll probably save it here too. Living entity. Not listing entity. Okay, and we also need to specify the activation zone distance. And the deactivation zone distance. Activation zone distance. Okay, so let's save these properties. Here, I'm just going to give it a bit of a shorter name here. Like that. This dot activation zone dist is equal to activation zone distance. Okay. So what does it need to do? Let's implement the event handler. I'm pretty sure there's also a dispose method in here, right? Oh, there's no dispose. Okay, we're going to need to add that in to entity components. So we want to be able to know when the entity gets removed. Oh, there's remove. Okay. Okay, so we need to register this event manager. So this dot add to event manager, and when the entity is removed, we need to remove it from the event manager. So basically now with this class, we can handle events. So the event we're going to handle is an entity move event. So on entity move. So basically, whenever an entity moves, this event's going to be called, and we need to check a couple of parameters with it. First of all, we need to create a target variable, and it should initially be set to null, so target is equal to null. Whoa, what was that? Okay, it imported it correctly. So basically, if event dot get entity is equal to target, so if the entity is the target, then we need to do some things. So we need to check if it's outside of the activation zone. We also need to update the direction that this entity will be moving in to close up on the player. If it isn't the target, then we need to check if target is null. So if that isn't the target and we don't have a target, then we need to see if this entity that moved, if it's a player, and that it's in a map, in the same map that we're in. So if event dot get entity dot is player, and event dot get entity dot get map equals living entity dot get map. So if the entity is a player and they're in the same map as this current entity, so this would be like the slime or whichever entity is using this component, then we need to check if it's within the distance, the activation zone distance. If it is, then we can target it. And if not, we do nothing. So we basically need to use a distance formula, but we're going to avoid using square root because that's a bit slow. So here's how we end up doing it. So if okay, so it's what is the distance formula again? Hold on, let me just check this out real quick with the math. So it's c squared. I'm going to use my drawing tablet because this is a bit annoying. Oops. Okay. And of course it's gone onto my second screen. I don't know why it does that. It's a bit weird. Maybe I can change it here. I think I've tried using this before. Anyways, I don't want to. Okay, so c squared is equal to a squared plus b squared. So basically, treat it like a right angle triangle. So just say this is where a slime is, and this is where the player is. We have the x distance and the y distance. And c would be this, so the x could be a, or it can be b, doesn't really matter. and the y would be b, or the opposite of x. So getting the distance would be c is equal to square root of whoops. So it would be x squared plus y squared. But a better way of doing it, of course, because we want to avoid using square root, because square root is pretty close. Yeah, math lessons with Video Boy. So I'm just going to show you guys a bit of an efficiency. Just say this would be the activation distance. So just say it's 9. Since we know the distance, and we don't need the distance to use some calculation, we can just square this, and then we have x squared plus y squared. So this, of course, would become 81. And then, we can calculate all this other stuff. So we need to get the delta x and the delta y and square root those. So let's do that. So we'll use floats. If delta x, well, not if. So we'll create a float called delta x, and we'll set it to living. Just do entity get minus then get entity get we should probably be using the foot x anyways. So we're going to be doing this calculation based on the foot position of the entities. Okay, so that's a delta x, and we also need the delta y. Okay, so delta x times delta x, so that'll be delta x squared plus delta y times delta y, so that would be delta y squared. If that is less than this dot activation zone distance times this dot activation zone distance, then so that means it's within the activation zone distance. So I'm gonna have to comment this after. This dot target target is equal to, we're gonna have to cast it as well, player event dot get entity, and there you go. So if we don't have a target and entity is a player on the same map. Sorry, I was just thinking about something else for a second there, kind of. Check if within activation distance I don't like this activation zone distance. I feel like it should just be activation distance. It's okay. I'll just leave it. If within set as target. Okay. So I'm going to create a boolean here. This is what I was thinking about. Because basically we're going to have to calculate the direction that this entity needs to move in to go towards the player. Let's change this. Yeah. Like that. Okay. And then in here we're going to have a tick. We should just do tick of 20, I think. Let's do 60. Okay, so now we're going to check if we have a target. So if target is not equal to null. Oh, right, we still need this other condition here, I forgot. Because we need to check if the entity moves out of the activation distance. That's the main issue. Event.getEntity. If event.getEntity is equal to target, else we do this. It's just for the event handler, we have to return whether the event was handled. If we don't have a target, so yeah, that should be okay like that. So if we're gonna have to calculate this distance again, actually. So let's just copy this. Whoops. Like that. Then if, let's copy this. That's going to be a little different. So of course we're going to be setting target to null. So that means we don't have a target anymore. If it leaves the deactivation distance, so we have to change this to deactivation distance. Also, it's if the distance of that entity is more than the deactivation distance. And so it's the opposite of this. It's not if it's within the distance, it's if it's outside. Check if target left deactivation distance. If so, remove target. Okay, there you go. So now we actually need to move the player towards the sorry, we have to move the entity towards the player. So I kind of wanted to try to avoid using a tangent function in a you know, like reusing it in a physics, in a game loop, because it's pretty CPU intensive to actually use trigonometry functions. But I think we're going to have to, because the slime's going to be constantly moving, and the player's probably going to be moving a lot too once they're engaging a slime. So we know for sure that if we don't calculate it on every tick, we might have some issues that might go out of bounds, like the slime might be going in the wrong direction to go towards the player. So yeah, we need to move it towards the player. So I did a little bit of research for doing this. Well, I've already done it in a game before. So I'll just kind of show you guys a little bit the way it kind of works in Java. So in Java you have a math class where you can do some pretty cool math functions. And the one we're going to use is a tan2, which is basically the inverse of tan, but we can also use like an x and y coordinate. And with that we can get the angle in which the slime should move to get to the player. So yeah, I'm thinking, because I just want to use a tan to get the angle, and then depending on the angle, sorry, I'm tired a bit. Depending on the angle, we're going to move in one of the 8 directions. So instead of like moving directly to the player, I think we're just going to, you know, do it that way. Yeah, because otherwise we're going to have to use sine and cos, and it's going to be even worse for performance. Okay, so we're going to save it here. So we'll have a double angle is equal to math.atan. And we're going to need this again. So it's inverted, so it's dy and dx like this. But that gives it to us in radians, so we're going to have to do a conversion. Thankfully they have that in the math class, which is nice. Otherwise we'd have to do, I think it's pi divided by 180 times that or something. I'm not too sure. And we can change this to target. Okay, so I did a little bit of tests before doing the live stream because I wanted to make sure I knew what I was talking about before doing it. Here, let's do a new one like this. Don't save. So basically, just say this is our slime here. Actually, I'll use green just so it's a bit easier to identify. And so the player can be anywhere around in any direction. And there's 8 directions. So it's a little weird the way it's split. Whoops. I'll use this line tool here. So it's kind of split like this. And it's also split like that. So it's like if the whoops, that's one thing I find annoying with Paint. So it's like if the player is, you know, like in this region, then we want, of course, we want the slime to move upright to go towards the player. But the player can be like anywhere in here, right? It's still going to move upright, so it's going to move like this. But as it gets close to the player, it can always adjust its movement to go to the side like that. So it's not going to be perfect, but I think it's okay. It's going to work better with the animations in the end. We'll see how it looks. We can always change it up after. And of course there's the other directions as well. So when I was doing my tests with a tan, basically it returned several different values. So just say we, here, why don't I just use the circle tool? So Paint's really not that good. So the slime would be in the middle here. So it's basically split like this. So in here, if it's below the slime, if the player is below the slime, it's going to give a value, a negative value for the angle, and if it's above, it's going to give a positive value. So basically, if the player is exactly horizontally aligned with the player, but it's to the right of the slime, so just say if the player is exactly here, the angle it gives is 0. But if it's exactly the same vertical alignment, but it's exactly on the left, it gives 180. So just say like it's, here, that's like 45 degrees. So it would give negative 45, no, not negative 54, negative 45 here. And if it's like 45 degrees here, it would give positive 45. So basically we need to kind of figure out which direction to go based on the return angle. So we're gonna have to use a few if statements there. And basically, so there's 8 directions, so we need to do 360 divided by 8 so we can figure out how wide of an angle that each direction has. I think it actually gives 45. Yeah, 45. So each direction has 45 degrees. So basically, if you wanted to go, if the player is to the right, then we have, I don't like how it divides because I have to do 45 divided by 2. So it's 22.5. So if the angle returned is between negative 22.5 and positive 22.5, we're going to go left. And if it's 22.5 positive plus 45, it's going to go, up left. And then if it's whatever that number was plus another 45 degrees, it's going to go up. And you guys kind of get the idea, I guess, right? Like that. This actually reminds me of VVVV a bit. So yeah, let's calculate these all in advance. So I'm going to get the eraser here. Erase all this. And this would be negative 22.5. So 22.5 plus 45 is equal to 67.5. So negative 67.5. And this would be positive 67.5. So if it's within this range, it's going to go up right, sorry. Okay, and then we add another 45 degrees, so plus 45. And that gives us 112.5. And this would be negative 112.5. And we have a full other 45 degrees, plus 45. 157.5, and this is negative 157.5. All right, so let's write out the if statements for that. So no, let's not do it like that. So if angle is less than 22.5, and greater than negative 22.5. Whoops, I didn't. And angles like that. Let's do a comment here to say that it's left. We'll have an else if here. So if angle is greater than or equal to 22.5 and angle is less than 67.5, I keep getting this wrong. I keep saying left, but it's actually right. Here, I'll just copy this here. Stop with the pop-ups. That's another thing I don't like with IntelliJ, is when I'm trying to type something, it does like this auto thing, and I can't use my arrow keys to go up and down to the next thing because the auto thing is there, the auto pop-up window, and it just scrolls through the pop-up window suggestions. It's super annoying. I'm like forced to use my mouse in it. There must be some shortcuts, but it's not very intuitive. No, if it's greater than 67.5, but less than 1112.5, up. It's greater than or equal to 1112.5. I should probably be using constants, but I think we're going to be using a lot of constants for nothing if we do. And we're not going to have to change these values. We know that they're good, so there's no point. And this would be up left. And we'll handle the all the way left as the final else. So let's do, we'll do down right. So that is, if angle is less than or equal to, it's a little bit weird doing an inverse, negative 22.5. And it's still greater than negative 67.5. Yeah, I know, but that's annoying. Like, why do I have to press another character to get out of the pop-up window? Like, if I'm done writing my line of code, the pop-up window should just disappear, right? But it's still there, which is what I find the annoying part. Angle is less than or equal to negative 2.5, and angle is greater than negative 157.5. Alright, almost done. So that's down left. And we can just basically do an else statement. You should do one for if it's equal to 0, like if it's right on the player. Although that, I don't think that would happen. It's fine. Okay. So basically now we need to set the direction of the player and also make it move around. Actually, one thing I want to do is if this slime is within a certain distance of the player, I just wanted to stop moving and instead it would like attack or something. So that would save us some efficiency here. So private static final int attack distance. We'll set that to 4 pixels. If dx times dx plus dy times dy is less than or equal to attack distance. So if we're within the attack distance, attack the target, and if we're not within the attack distance, then we'll move. So that's a little bit more efficient that way. And also it makes it so that once the slime is right beside a player, it's not gonna just like, you know, like if it's the slime and the player's right here, and then next frame, because the player's still a little bit to the right of the slime, then the next frame the slime is going to, you know, move a little too far away from the player, and then it's going to move back. It's going to be back and forth, so the slime's going to end up just like vibrating back and forth really fast, which is actually a bug that I've had in the past. And the distance, the the solution was to check the distance like that. We don't need this diagram anymore, I don't think. One other thing I want to put in here is I want to have a way of knowing what the walk animation is of the entity. So if, no, not if, I keep saying if, but move animation ID. Whoa. Oh, neat. This is on my drawing tablet. I accidentally pressed on the buttons. I can easily do that. It's even an undo button, which is cool. I had no idea. What happens if I do erase? Oh, it's just the letter E. I'm gonna have to configure this drawing tablet. I did it in the past once, and I didn't do it ever since I got my new computer. Okay, so basically, I think there's a way to move entities, right? If we do living entity dot move, there you go. Okay, so let's set the direction of the entity. So living entity dot get pose location dot set direction dot right. Okay. So that's going to set the direction of the entity. Now we actually need to move it as well as do the animations. I think, yeah, the diagonal factor. Actually, I'm going to add this into the living entity class. Let me check here. Where's living entity? That's interesting. Get pose if moved in direction. Hold on, I'm kind of thinking about how I'm going to do this in my head. Okay, so this is a method I want to create that will return a vector of the new position if this entity moved in a certain direction at its speed. So this will make some things quite a bit nicer, I think. Speed moved. Why are we keeping track of speed moved? I don't think I end up using speed moved, right? Okay, so basically I'm just going to abstract everything for entity moving, like living entity moving, into the living entity class, and I think we can actually get rid of some things. Like this speed move variable, I don't think we use it anymore. I used to use it for cheat prevention, but that's not very good. So you can use get speed here. Oh, there's an error here. Yeah, so we can actually end up removing all this in the player and just use the version in the move method here. So we can actually check the collisions in here, and I think it would just make more sense like that. So we don't need this. Check collision. So I guess some entities can avoid checking collisions, like they don't need to. Okay. That's one thing with Livestream, I can't use two screens. Well, what's all these errors here? What's this here? Oh, right. Okay. I should have a Boolean value here that will return whether it's successful. This, if super.move. Okay. So basically now we're going to put everything inside of here. So we need to check. So first of all, in the move, we need to calculate where the entity will end up moving. So let's copy most of this here. So this line of code here, I think, should be somewhere else. Anyways, let's just do it. And this should not be using new pose. We will create new pose. So vector2 new pose is equal to new vector2 at the player's current position. So it'll be this dot get location dot pose, like this. I should just do location dot pose. Okay. Right, so it's complaining that there's no default case, but that's fine. I don't need a default case. Yeah, we'll do incomplete switch like this. Oh, right, we're going to need a delta time here as well, so float delta time. Like this. Alright, so let's do a comment. Calculate new position. So basically, everything relating to up, left, down, right positions, we are basically checking the up and down differently. Hold on a second. I think there might be a bit of a bug here. No, it's probably fine. Okay, so we need to check if, yeah, I wouldn't worry too much about that thing I said before. Okay, I think I'm going to need to split these things up a bit. Private boolean move. Okay. That's the main thing I'm concerned about, because if we're going, I should just ignore that for now. Because, okay, basically it seems like when we're moving down right and down left, the position is being updated twice. At least that's what it looks like. But of course that's not what we want. Okay, so if there's a collision, okay, so if it doesn't collide with map, or does current position collide with map? What is this current position collide with map thing? Okay, this should be in the living entity class. I think that was so that if something happens, like the entity is stuck, like if a player gets stuck, you know, like, just say there's something collidable all around them and they can't move out of it, this will make it so that they can move out. So I add that in as a bit of a safety feature. Okay, yeah, I'm gonna have to fix that after, once I'm done doing all this stuff here. Okay, so I'll change this to new pose 1. Does current position collide with map? Okay, so if the player isn't colliding with the map, or if their current position already collides with it, then we need to move the player. So let's create a vector 2 here called new pose. Called the new vector 2 location dot pose. Then we need to set new pose dot set to new pose 1. Okay, I'm going to leave it as a full curly brackets one just because we might end up changing it later. Okay. And now we have to create a new pose 2. And we'll use this. Call that new post by accident. Okay, and we basically need to do the same thing as before. So we need to check if it collides. So the reason why we're checking the horizontal and vertical directions separately when we're moving the entities is so that just say you collide horizontally with like the side of the water or something, but you're also moving vertically. It'll give you the chance to still move up even though you're colliding horizontally. So it's kind of nice the way it works out like that. And this should be using new pose. Like this. And it should be new pose dot set to new pose 2. Right, and then it creates the event. So create event and check. And we only need to check if it collides, if check collisions is on. So we can avoid doing collision detection if the entity doesn't require collision detection. So we can do that. It's a bit of an optimization here. So if check collisions, I have a feeling that's good. I just want to see something in here. It is moving. I think the move here should use the so it needs delta time, it needs check collisions. We should also give it a direction option, just in case you want to move into a different direction than the current one. Like that. And we should do another one without the direction. Return this dot move location dot direction delta time check collisions. Move entity in the Okay. We should add the parameter thing here. Direction. Okay, cool. So in here now, we should be able to remove a lot of this code. I'll leave that there. This can all be moved. It'll just be deleted actually. Ah, this mouse is annoying. We don't need new pose. So now in here we should be able to call this dot move. Ah, right, we need to adjust this here. So now we call this dot move. We can pass in that new direction, and we want to check collisions. We set that to true. There you go. We can remove this warning here. So there you go. Basically just cleaned up the player class code as well, and now we can also reuse it for the slime, which is really awesome. This it's just a comment from the other programmer. I'll put a comment so you can understand it. Do not change. No. Changes direction if it is different and lock is off. Okay. Entity type. This should just have that. This should just have that like that. Okay. I think that's pretty good. Of course, we have to test it to actually make sure it all works and everything, but I'm just going to check the code real quick. So basically we have a new position here, which we're setting to the current one, and then we're checking the vertical axis if something changed. So actually I'm going to rename this to new pose vertical. I'll change the other one to new pose horizontal. So it's checking, it's moving up and down, and it's seeing if there's a collision, then don't move it. But if there isn't a collision, then move it. So set the new position to the position vertical. And we're basically doing the same thing here, except we're using the new position as a starting point. And then we're setting it to the updated horizontal one if there's no collisions horizontally. Once that's all done, we have our new position, so we can run the event, passing in the new position. And then there's all this stuff for calculating whether this entity stepped on another one and keeping track. Yeah, I think that's it. I think it looks good. So now we have this monster follow component. So we're setting the direction based on that. And I think now we can just do living entity dot move like this. pass in the delta time, and we should also, yeah, I guess we should check the collisions for the slime, right? We don't want it going through walls. I think that's it. You can close all this up because we're not going to need all that space anymore. I won't remove these curly brackets just in case we actually do need that space, but I don't think we will. So calculate direction to move entity based on angle to player. Move the entity in that direction. And what is this condition for? If target's not equal to null. If we're moving, we should also set the animation of it. So entity dot get where do I set the animations? I think I made the animation manager private. Here, I'll go make that public real quick. Alright, just created a getter for that. So entity.get animation manager, and dot change will set the animation to we didn't even save it here. Protected string move animation ID. This dot move animation ID equals move animation ID. Like that. And I think we should change the animation to an idle one, so we're gonna have to save an idle animation as well. I'm going to try to think of a better way to do it instead of having to pass in all these animation IDs for different things. I'm sure I'll find a better way to do it. I just have to think about it first. Okay, so if it's within the attack distance, we'll set the animation to the idle animation. I don't think there's a whole lot left. I think in here we should keep track of whether the entity is moving. So public boolean is moving. Returns whether this entity is moving. Currently moving. And we should have a Boolean variable keeping track of that. Okay, so if it's in the idle animation here, we should set moving is equal to false. But if it is moving, we should set moving is equal to true. Return moving like this. Okay, so now we need to actually add in the component. So it'd be protected monster follow component. And we need to add in the component. So components dot add follow component. We need to define follow component as well. So follow component is equal to new monster follow component. So living entity is this. The idle animation ID will be default. And the move one, we called it walk. We changed it. Activation zone distance. We need to get that from the full snapshot. Get int. What do we call it exactly? We call it activation zone distance, right? And the default value will create a final variable for that, so we'll call it default activation distance, like this. Full snapshot get int deactivation zone distance, like this, and the default value will be default deactivation zone distance. Okay, let's create these constants here. So private. We'll actually put it in the monster follow component. So where is that? Public static final int default activation distance is equal to let's say like 3, no, not 3 tiles, that's not a lot. We'll say 100 pixels. The default deactivation zone will put 200. Okay, there you go. And this is not... Here, we'll just remove this constructor, because we should not be creating slimes that way, so it'd be a bit weird. Is moving. Okay, so now we know how to tell if it's moving. We use the follow component. Is moving like this, and animation complete. There aren't any animations that can complete, so we'll just leave that to the default value. Okay, so now let's actually add in a slime. And we'll see how it worked. I mean, who knows? It could have been completely bugged up. Okay, so let's remove some of these things here. We don't need this. No, we don't need that. Actually, we need to test that the player movement also still works. That's pretty important. Okay, so let's add in the slime now. So let's put it kind of close to the sword sign, maybe a little bit south. So we'll give it a name. We'll call it slippery slime. Type is a slime, and we go into its properties. So its position we will set to let's put it a little underneath. Let's do 400x, and the y will do 500. Keep it simple. Health set to 100. Style 0, we don't need to say that because it's the default thing, and we won't give it activation zone or anything like that. Let's just set its direction to 2. Alright, let's try it out. No guarantees it's actually going to all work. Like even the player movement, I'm not too sure if it'll work in the end, but because we changed a couple of things with that. Maybe I missed a couple of little details. There's a lot of copy pasting, so. Oh, load from file. Slime default. Oh yes, of course. There's no such thing as a default, right? And we also have to do as _0 for that. So we have to specify a file name. I don't need the quotes here, but I just do it anyways. And it'll be walk. But I also need to put _0 because the style is 0 for this entity. Whoops. Okay, there you go. Oh, null pointer exception. That's on the server. So create entity by snapshot. Huh, weird. Oh, we didn't specify it on the server, that's why. I thought we did for sure. Okay, we're gonna have to do the same thing as we did before here. Might as well import all the entities because they all need to be defined here anyways. Okay, I have to restart the server too now. Alright, that was much faster than before, that's for sure. We'll get the client online. Yeah, look, there's the slime, but it looks like he's going away. Maybe there's a bit of issues with our calculations. Also, his health bar looks huge for some reason. Oh, and there's some issues with the collision detection here, apparently. Okay. Let's go back in the living entity class here and let's see what's up with the collision detections. I am using true, right, when I'm moving it? Yeah, true. So it should be checking the collisions. New pose vertical. Ah, yeah, it's this here. This should be new pose horizontal. That's why. I think if we're moving directly down, then we can't. Then we do collide with the map. That's the main issue, I think. Okay, yeah, there you go. That fixed the collisions. Okay, the slime is still trying to get away. So it seems like he's going in the opposite direction that we need it to. So yeah, that's definitely a bug that could be happening. So let's just try doing the complete opposites here. Oh, I think this calculation is telling where this entity is relative to the player. So yeah, it should be the opposite. That makes complete sense. Left, and then this should be down, left. Wait, that was up, so this should be down. Should be down, right. Should be up, left, up, right, and then right. We don't need these comments anymore, actually, because we can see the directions when we set it, so. Whoops. Okay. Wait, we have to restart the server though, so that it's good. Alright, where's that slime? Oh, there he goes, going towards us. But the direction he's facing is backwards. That's weird. It's like it's not being updated. But if we get out of it, he should stop following us. Well, now he's stuck in a collision. Here, let's try to run away from him. We go 200 pixels away. There you go. He stops following. And it's like the animation stops too once we his direction doesn't change. Number of directions. Okay, so we set it all to 8 like that. Maybe we just specified it wrong here. Default idle animation, yeah, move. That should be fine. Saying default and then walk. I'm just wondering why the direction doesn't seem to be getting set here. Maybe somewhere in here we're overriding it. Here, let's look at the location variable here. I think it's in the source shared. Nope. I mean the location class, rather. Here, I can just do this. Open declaration. Okay, so that just sets the position, so it doesn't bother with the direction. So that's good, that's what we want. Doesn't seem like the direction is set anywhere else. I think this animation stuff, I should change it a bit here. So I'm not going to do it this way, because I think that's not very smart anyways. We're going to override tick 60 here, and we're going to do if is moving, and we'll do this dot animation manager dot change, and we'll change it to a walk. Else this dot animation manager dot change to default. So the monster follow component shouldn't have to take care of the animations. I think that's just a bit weird. So we're just going to do it this way. I think it makes more sense like that. So it's just going to keep track of whether it's moving or not. Okay, so let's see what that changes. Should change a couple little things. Yeah, the stream seems to be not doing too bad today, actually. Pretty happy with that. Oh, can connect to the login server. I added cheat prevention for the login server, so you can't connect to it more than once per second from the same IP address. So when I start the server, it connects to the login server, and then when I start the client, it also does it. It's like the direction still doesn't change. So when I connect to the client, it also connects to the login server. But since it's the same IP, it causes some bugs. Alright, if he gets close, he should stop moving. And I think attack distance should be a little different. I'm thinking I should change it to Um, like the width of the player. So we'll do target dot get is there a way for me to get the foot collision rec of it? So I guess we could do dot get type dot get okay, well the player will always have at least one collision rec. So if we do get collision recs 0 dot width, that should be okay, I think, like that. But still though, the direction of this guy isn't changing, which is a bit weird. But he is moving in the right direction, it's just he's facing the wrong way. Maybe there's something that's... And the animation is still off as well too, which is kind of weird. I want to see something here real quick. Okay, so I'm going to make him follow me underneath and I'm going to run away real fast. Okay, and I want to see if he's facing under once he stopped moving. No, he's still facing the same direction. So that's about 200 pixels. And if I go to the halfway mark, which is probably around here, he should start following me. There you go. Yeah, let's look at the slime definition here. View rect width and view rect height. Now why are they at 90? That's what I'm wondering as well. There's a couple of little weird bugs happening here. Where's that? Entity type data. And let's go in the client here in the entities. No, that's a server. I want to see where we're rendering the health bar. What it's using exactly for the width and the height. It's using the view rect width and height. That's the thing though, the view rect width and height aren't that big, so why is it giving 90? I think every time I live stream I discover some little bugs like this and we have to fix them. It's like, where are these coming? Where are these things coming from? entity type.get view rect. Oh, maybe it's, maybe I think I might know. Yeah, I should be duplicating this view rect instead of just moving it, because I think that causes some bugs actually. Like this. X and Y. I think on the server I have to do that as well. I think it's just some issues where it's like, I don't even think that would fix that bug though. I really need to find where it is. Entity type, well, let's do that anyways in here. So collision rect new view, whoops, view rect is equal to new collision rect. Maybe I have previous servers running? No. Should remove this. So it has to be moving with this. It's just, why is the direction not updating even though I'm setting it? It's like it's the visible direction that doesn't update, it seems. But the thing is that here I do specify that it's almost as if that the client isn't loading this in properly. Like there's some issues loading in the definition for this entity. Okay, I'm going to do some stuff on the client here. I'm just curious. If I do update, let's do a system.out of a couple little things here just to see what's going to print out to us. We'll do this dot get urect.width. Let's just start with sure, that's fine. Okay, the direction's not changing on the client because we're not putting in the changes snapshot. Okay, I just remembered that. 24. Okay, I remembered that at least. But why the slime health bar is rendering so large? That's what I'm really wondering. Yep, I use libgdx. Oh, maybe because its health is higher than its max health. That's probably it. Max health is 30 and I set it to 100 in the definitions. See? That's what it is. Aha. Thank you. Okay, so that should fix the health bar issue. Yep, there you go. Okay, now the direction change thing is not that hard to change out also. Okay, so we can remove this now because we don't need that. So we need to save the old direction. So old direction is equal to entity dot get location dot direction. And we basically just need to check if old direction, we'll just do it the other way around. So if entity dot get location dot direction is not equal to that, so basically if it's changed, then we need to do entity dot get change a snapshot, and we need to add in a new change. Dot put int direction. I'm going to change it a little bit. I'm going to put it, this is the client, right? I'm going to make a method that will just update the direction. It'd be much easier so I don't have to memorize it every time. Nope. Location direction. I think after this I'm going to end the stream. I'm going to end a little bit early. Or maybe not. Well, I'll see. Whoops, I gotta go get this call. I'll be right back. Alright, I'm back. Okay, so I think that's the right way to set the direction if it's changed. Let's go into the player class again, because I know for a fact that it has it written correctly in here, so. Location.direction.ordinal. I think that's the equivalent, actually. It should be okay like that. Okay, so that should change the direction properly. Don't need to keep track of old direction in here anymore. I don't use the hierarchical package manager. I'm not too sure what you mean. I guess there's another thing in here, right? I guess you're talking about the package explorer like this. It's like the same thing almost. And what do you mean bug? Did you notice something I did wrong, or? There you go. The direction of the slime is updated. He kind of glitches out a little bit there and he's getting towards me, but the movement's a little weird. It just keeps shifting back and forth like that. Sure can figure out a way around that. I feel like the deactivation distance is maybe a little too far. So I'll just update that quick, and then I'm gonna go for a couple minutes. I need to do something real quick, and I'll be back. I'll do the full 3 hours of the stream. I mean, there's not a whole lot left anyway, so I think 150 is a good deactivation distance. Yeah, there's a little arrow for the package. Oh, like this? That's kind of neat. I'm gonna have to learn a little bit more Eclipse this summer. There's a few things I need to learn this summer that I have some time to, so I get more used to using like shortcuts and stuff, and you know, things like that, features, get better at debugging, different things like that. Anyways, I'll be back in a few minutes. I'll just put the be right back thing on. Okay, hold on. I'm not officially back, but yeah, I just figured out what you were talking about. You mean this, right? Yeah, I was wondering how people did that. I think I'm going to start using that instead. I think it's better. Thank you. That looks actually much nicer. Okay, now I'm going to go. Alright, I'm back. Sorry about that, guys. But yeah, I want to add in an entity spawner. I forgot we were going to do that today, so let's do that. I think that'll be a lot of fun, actually. So the entity spawner is actually going to be an entity that it itself has a snapshot that it uses to generate other entities, which I think will be super awesome. So yeah, let's create it. Okay, let's start by creating the definition file for it. I don't think it should take too long, although it might not work exactly as intended because I need a way to know if entities are dead, which I'll add soon, probably tomorrow actually, since we're going to be doing the actual combat. Yeah. I have to do the game over screen too as well once you die. But yeah, once we know once entities die, then we can the spawner can keep track of how many it needs to how many entities it should have in the game world, right? So yeah. Okay, so shared. Let's create this. We'll call it a spawner. So ID is spawner. I'm just not going to put the quotes. Hittable is equal to false. I should keep it as true. We don't need a speed for it. We don't need a health. Footstep sound, we don't need that. Image width, image height, we don't need that. View rect, blah blah blah, we don't need all that stuff. Draw order, we don't need it because we're not even going to render it. So collision rects, we don't even need that. We don't need animations. I think for the purposes of it, we should have an empty image to render it. So let's create an empty image real quick. Paint. No, because Paint doesn't have transparency. Let's go pixel edit. So the image width and height will be 1. Same with the view rect. Number of tiles, no, it's just going to be single image. 1. There you go, and that's it. We're just going to export this. Desktop. Oh, hey, there's been a lot going on, chat. Yeah, sorry. I was gone for a little longer than I thought. Maybe do instance of call method in a class. In all class implement. Yeah, well, it already does that. Well, entity components aren't necessarily they aren't necessarily event handlers. I can show you real quick if you want. Here we have event handler. So see, these are the methods we're using to add it to the event handler. So we have an event manager that we add event handlers to. So when you call add event add to event manager, we know it's an event handler because we're adding in this. Also, the event manager requires you to use an event handler when you're adding it. So yeah, you don't need to check the instance because it's implied. Also, this method is part of the event handler, so you know for sure. Here I can show you the event manager if you want. Let's see, add. Okay. So this image should be in there now. Thank you for this, by the way. I think it's actually really nice like that. I wasn't expecting to really want to use it, but I think it's cool. The hierarchy mode. Okay. Refresh that. So now we have the spawner image here, which should just be a blank thing like that. Perfect. So we're gonna have to define an animation, even if we're not using one really. We call default. Total runtime is 0. Number of directions 1, which is the default, and we don't have to specify if it's looping. We'll just keep it like that. And there's some properties for it. So we have one property called spawn width, and it's type int, and we also have spawn height. Spawn amount, and we're also going to have a spawn rate. This we can set as a float. Okay. The spawn rate is going to control how fast it's going to spawn in entities once older ones die. Spawn amount says how many entities, and spawn width and height is the region in which it's going to spawn entities. So yeah, I think that's all for this. Of course, we can have other entities that inherit traits of the spawner that you can actually kill too. So we'll have that as well, which I think is neat eventually. So you know there might be like an egg, and you can kill the egg so it will stop spawning entities, like entities that are hatching from the egg. So that kind of thing, I think that'd be pretty cool as well. We won't do that today though. I mean, I don't want to do too much longer in the stream anyways. I just like to try to get this in. Okay. So let's create the classes for it. So in the core, there's probably going to be nothing in there like usual. So it's a lifeless entity as well. I'll call it a spawner. Okay, and it doesn't do anything on the client side. That's fine. This is the client, so let's add it in here. Right, and let's add it to the server now. Lifeless. Animation complete. It's not going to have any animation, so we'll just keep it the same. Keep this class open because we're going to be writing some stuff in there. Add it to the entity type here. Okay, And I guess it's in the game now. We should just add it to a map, of course. Okay, so how is it going to work exactly? The way this thing is going to work is we'll keep track of some sort of ID for the entities it's going to spawn. So protected, I'll make it private. Private next spawn ID. This is an int. Oh, and I forgot one actually super important property for this here. Spawn snapshot. This is the entity snapshot of the entity that this spawner will be spawning. And for the property definitions, I don't remember what object I can use for that. I guess JSON works. Let me just check. Yeah, I can write object. Which I think goes to a string, right? In the end. I should add in a new type map dot put. Okay, so we need to keep track of the snapshot that we're going to be using to generate new entities. So we can get that from full snapshot dot get object. And it's spawn snapshot. Current value is null. So by default it can have null, so the spawner can spawn null if it wants to, and the type would be entity snapshot.class. And this will be spawn snapshot is equal to. Okay, so we're getting the snapshot this way. And this should not be int, it should just be void. What else do we need? Yeah, we need those attributes here. So we need the spawn width, spawn height, the amount. I don't think I'm going to implement a lot of these things right off the bat. Could be not too bad. I think I might end it soon and then just continue tomorrow, because I have a feeling it's going to be a little bit more in depth than I imagined, so we might need some more stuff Private. And spawn rate. Let's put this. I like using this in the constructor when you're referencing similar things. This dot spawn width is equal to full snapshot dot get int. Give a default value of 100. Spawn amount. I think a good default value would be 4. And spawn rate. So this will be how many will spawn per second, I guess. So we can say 0.5. Okay, so now we have all these attributes here. So let's take over tick 20 here. And let's determine whether we should be spawning in guys. So until we add in the death stuff, for when entities die, for now we're just going to be spawning them in constantly, so we won't keep track of the spawn amount. Yeah, so we won't keep track of the spawn amount, but we will do the spawn rate. So it's just going to continually spawn them within the width and height of the spawn location. So I think that'd be cool. So we'll do private float timer. So we're gonna have a timer for the spawning. This dot timer is equal to 0. So timer plus equals delta time. If timer is greater than spawn rate. So normally we're only going to run this code if we're missing entities, right? So timer minus equals spawn rate. And we can spawn a new guy in. So whenever the timer goes over, we can spawn a new guy. I'm thinking of changing this to like seconds between spawn instead. So let's do 3. Yeah, no, that's how it should be, I think. Because otherwise we'd have to do 1 divided by spawn rate. But like this, it's fine. So we'll spawn a new guy. And we have to do a couple of things first. So we need to get... Hold on, I'm just going to add a suppress warning for this. We need to get a random position within the spawn width and height. So let's do that. I think it is saved as a vector. Hold on a second. I need to check the way I did in the entity class here. It's saved as a point. So point. p is equal to new point. Okay, so float x is equal to static tools dot get random dot next int. So the bounds will be the spawn width plus this dot get x. Okay, so that'll get a random x coordinate, and this will get a random y. Okay, and now we need to generate the unique ID. So it'll be a string. We'll call it name, because that's how we call usually entities. Name is equal to spawn snapshot dot name plus, I'll do underscore in between, plus whatever was next spawn ID, like this. And you could do next spawn ID plus plus. So this will make sure that the entity has a unique ID. Okay, then now we just need to okay, I'm going to make it so it's possible to duplicate the in the entity snapshots, it's going to make it possible to duplicate the entities. I mean the entity snapshot. Okay, so this dot name is equal to snapshot dot name. Dot type, do snapshot dot type. This dot anim is equal to snapshot dot anim. So basically, I'm just making a cloning constructor here. So this dot anim time is equal to snapshot dot anim time. This dot anim meta is equal to snapshot dot anim meta. This dot foot. Oh. This dot foot sound is equal to snapshot dot foot sound Don't even know why I bother with that. I just feel like that because I do it with the array list anyway. So okay, so for I think it should be entry set like this. String property in properties dot entry set, like this. So it's a set of entries like this. Map.entry. Hold on a second. Yeah, so it returns a set of entries. Oh, right. It's like this. This dot properties dot okay, there you go. So that should duplicate clone constructor. Okay, so entity snapshot duplicate is equal to new entity snapshot using the spawn snapshot, and then now we need to duplicate dot name is equal to name, and duplicate dot put object pose, and we need to put point P. Okay. Now we need to actually go onto the map and spawn in the entity. Hey, 13 viewers, welcome everybody. If you're new, please subscribe. Oh wow, we're already at 3 hours and 5 minutes. All right, I'm gonna try to finish this up real quick here. But if I think if I get into a bug, I'm just gonna end up stopping because I'm getting I need a little bit of a break now. I think over the summer I'll get used to talking though for so long. But actually here, I just want to show you guys real quick. I have a new update schedule, new live stream schedule up for the whole summer. So if you guys want to watch the live streams, I'll post it in chat. But be sure to check it out. Oh, and yeah, sorry, I didn't check in the chat. Oh, nice, you got some networking to work. Oh yeah, that's true. Yeah, I forgot about the add all method. And yes, I am working on a networking tutorial. I'm currently writing the script, and then soon I'll be actually recording the footage. But it's still fairly early. I'd say it's probably going to be out in a month or so. Because I also I'm going to add, for the tutorial, I'm going to be adding in networking to the platformer tutorial as like a demonstration so you guys can see an actual implementation. But the video tutorial is going to be very, it's not going to be an actual implementation. I'm not going to show you guys how to program it. I'm just going to show you guys how it works. So people can watch the video and program in any language using any engine. So yeah, I kind of want to avoid just doing like a Java tutorial on it. I really want it to be something that anybody can use. But I will do a Java implementation if you guys want to see some code though, so at least that. Okay. This dot get map dot add entity. So I need to spawn the entity. So entity is equal to entity type dot get create entity by snapshot, duplicate, and use get map. So this is going to create the entity using the snapshot that we just built and duplicated, and then it's going to spawn it into the map. So now let's actually, there's some import errors here. Here's a couple more warnings. Oh, I think that's in the map editor. Okay, okay, let's add it into the map now. So let's spawn this guy in. Wait, there's one thing I want to do quick. I want to disable map saving first, right before we do that. Otherwise I'm going to forget. Here, I'll just comment that out so it doesn't save the map because I don't want it to. Okay. So let's copy this because we're going to need this snapshot actually. Here, I'll open up a text document real quick. Okay. Alright, so let's add it in. So the name of it, we'll call it slime spawner. The type, of course, is a spawner. And I'll go into the properties. So the position of it will be, we'll do X is, we'll put it close to the sign once again. Maybe a little bit different place, but let's do 400, and the Y we'll put much lower. We'll put like at 450, so Y 450. We don't need a health, we don't need a style. Okay, so now we need to go into the properties here. So spawn width, spawn height. Let's just do spawn snapshot. We'll use the default other properties. So spawn snapshot. Okay, so now we need to put in the string like this, and I need to put escape here. I'll show you. I need to put escape characters here on the on these. That should be okay. So we'll copy that in here. Throw that like this, and let's try it out. No guarantees it's gonna work, but it'll be fun nonetheless. If it doesn't work, I don't think I'll fix the bugs on stream today, because we don't know how long that can take. I'll just continue tomorrow. So, null pointer exception. Entity type. Okay, so if I don't specify collision rex, let's fix that real quick. Entity type data. Here, we'll just give these things empty arrays. Are there any other arrays here? Nope. Maybe the server had a hard time loading that too. That should be okay. I don't think it loaded in entities yet, so it only loads in things once it's needed. So server running without any players is not too bad. Load player using player data. Cannot load map. Okay. I probably did an something here. Maybe I can't use escape characters there. Maybe I should just use like a single quote. I think that'll work too. But let's just see if there's anything else. Actually, we don't even need to specify position for this thing, because it's going to be generated, right? So health, yeah, I'll do 30. Style and direction, just do it like that. Type slime, slippery slime. Oh, and this is wrong here. I need to put curly brackets around it like that. Okay. Let's try it now. I don't even have to restart the server, because if it's just an issue with this, it'll reload. Oh, it's taking a while. Oh, it's probably because the server crashed. Okay, yeah, I'll have to restart the server then. Oh no, still an issue. Load player using player data. Properties, position. Yep. Spawn snapshot. Oh, I have one too many curly brackets there. Should probably error handle that a little bit better. Okay, cool. Oh, that guy wasn't there. Oh, look, see? A couple of them spawning in.